Last activity, making predictions within and outside a data set. So we can see that these years are being composed, and we're probably going to want to predict future years, okay? Using technology to determine the linear regression equation for this data set. Now, I wish I had a better explanation of what is about to happen, but I'm gonna try something first. I'm gonna start with 1 real quick. I'm gonna do it on my own. Hopefully you're already inputting this table while I am just kind of gazing and doing it on my own real fast. Definitely do this on your own. Start bringing up Desmos, put in your own table. We definitely want you all to try it. Most definitely. Give me 1 more second. Almost done. Working as fast as I can, ladies and gentlemen. Working as fast as I can. Hope everyone's having a terrific day. So, let me see if I like that. I don't like that. Why is it negative? That's the question. Interesting. So, just like I had predicted, if we start with the year 1, it does not work out the way we should. So, let's see. The table shows a percent of total music sales revenues from streaming. I wish this gave you a better explanation of why this is not 1. Because I know in the previous activity we started with 1, but for this specific one, we have to start at 0. So, in my next video, I'll find a better reason to tell you why it's 0 and not 1. So, just start with 0. Input your table, ladies and gentlemen. Input your Y1 tilde MX1 plus B. I'm modifying mine real quick, and I'll show you it in just a second. Of course, if you need to fast forward, go ahead and fast forward, not a problem. If you're way ahead, that's not a problem. We love smart kiddos. Okay. Here we go. So I input that table. Like I said, I started with 0. And from this part, we can see that our slope is 5.57 and 4.90. Now, I don't like that 0, so I'm going to leave it as 4.9, but I'm going to round my slope to 5.6. Okay? So I'm going to label my slope as 5.6. This is to the 10th place. And my y-intercept is 4.9. Interpret the equation of the line in terms of the problem situation. So, we write this out. 5.6x plus 4.9. We have to say that this is the percent that it started, and this is the increased percentage. Now, there are these funny vocabulary words that, of course, I would love to go into more depth, but interpolation is basically, we're going to use this equation to find a data set that we already have, and we're going to compare it. It says we're going to use 2013, okay? So 2013 is number 3. I'm going to use the equation that we just wrote. Y equals 5.6x plus 4.9 Okay, I'm gonna press the gear. I'm gonna press the table. I'm gonna erase all that stuff because I don't like it. Again, we're looking at 2013, so that's number 3. I'm gonna type in 3. And it says 21.7. So the table says it's just 21, but our Desmo says 21.7. We want you to compare this and write a little statement why you think it's different. Pause the video, give yourself a few seconds to do that. And we want to do the same thing for number 4. So number 4 and number 3 is the same thing. And then right here is your big explanation, okay? Give yourself a few minutes, pause the video when you're ready to keep rocking and rolling, play the video all over again. Great, if you started it, wonderful. Extrapolation, because we like being extra, is that prediction part. You could even see the word predict right here because we're going outside of the table. Okay, so we're going to use these numbers to see what our predictions are. The issue is it's in 2040 and then 2004. Now, I'm going to put a star next to B because I really didn't like this when I was working it out on my own, but we are going to look at it in just a second. Okay, so 2010 starts at 0. I like that 0 because now we could say 1, 2, 3, 4, 5. So they want 2040. And then they also want over here, which is 2004, I believe. Let me go back. Yes. So this looks like it's -6. Don't ask me how I did that. No, I'm just kidding. If I went backwards, 2009 is -1. 2008 is -2. 2007 is -3. 2006, 2005, I'll just write it all out. 2004, so -4, -5, -6. So I'm gonna come back over here. This is basically saying -6. 2040, that's gonna be a tough one because I don't wanna write all that out. So it's 10, I believe it's 30, if I'm not mistaken. Double check so I don't waste our time. Yes, it's 30. Right here, if we count it, we will find out that X is 30. Okay, so I'm gonna use that data set. X is 30, X is 30. This is kind of like what we did last time. We made a table, X, X, this is 30, this is -6. Now let's see what our data says. So I'm gonna put a 30 right there. That says 172.9. My Y is 172.9. Now let's look at the -6. -28.7. Definitely do that. Gives you the extra practice for predictions. Now, are these predictions reasonable? We have to remember our story is talking about sales, which is money. So do we think that these numbers make sense? So definitely think about it and explain why you think these two numbers make sense. We would love to see it, okay? The last portion of this lesson, the talk to talk, it's all reflection. So again, whoever's in the room with you, they need to check that you're actually writing this out. Why is linear regression line generated using technology more accurate than the line of best fit with 2 points? And why are predictions by extrapolation more likely to be less accurate than interpolation? So definitely write your reflections and your own opinions. We would love to see them. You all did a terrific job today. Can't wait till the next lesson.